Have you ever faced a complex electrical circuit and wished there was a simpler way to understand its behavior to specific terminals? When working with circuits containing only independent sources, you determine Thevenin equivalent resistance, often called RTH, by setting all independent sources to 0, and then finding the equivalent resistance from the designated terminals. This approach transforms even intricate networks into a straightforward series or parallel combination of resistors. This method works because Thevenin resistance represents the circuit's intrinsic opposition to current flow, distinct from the energy supplied by independent sources. By deactivating these sources, we effectively remove their contribution to the circuit's active behavior, allowing us to see only the passive resistive network. This aligns with the principle of superposition, where we analyze the response due to each source type independently. To apply this technique, first identify all independent voltage sources and independent current sources in your circuit. Next, replace each independent voltage source with a short circuit, which means replacing it with a direct wire. Then, replace each independent current source with an open circuit, effectively removing it from the circuit path. Crucially, leave any dependent sources exactly as they are. Finally, calculate the total equivalent resistance looking into the terminals where you want to find the Thevenin resistance, using standard series and parallel resistance combination rules. A key insight here is understanding the fundamental difference between independent and dependent sources. Independent sources provide a fixed voltage or current regardless of other circuit elements, while dependent sources control their output based on a voltage or current elsewhere in the circuit. This distinction is vital because dependent sources contribute to the overall resistance characteristics of the network and should never be turned off when calculating RTH. If your circuit includes dependent sources, you would instead use a test source method, injecting a known voltage or current and measuring the resulting parameter. Mastering this technique empowers you to simplify circuit analysis dramatically, making it much easier to predict how a load will interact with the circuit. By isolating the circuit's inherent resistance, you gain a powerful tool for understanding and designing electronic systems without getting bogged down in every detail of the original complex network.